The lesson topic for this video is, I can calculate the number of permutations or combinations. Now, before we talk about actually calculating these values, we first need to understand the vocabulary. What is a permutation and what is a combination? I think this is one of the most easily understood examples. Okay, so if we have a gold medal, a silver medal, and a bronze medal, that means that there is an actual first place, second place, and third place. Most people think there's a difference between winning and getting second or third. So if you think about how the order in which you, let's say, run a race and finish is involved, if order is involved and important, that is a permutation. So coming in first, getting a gold medal is more important or more valuable than getting a second place silver medal or a third place gold medal. Whereas a combination means that order is not involved or not important. If you participate in something and you all get a participation award of some sort, that means not one person is not more important or not important, but did not finish ahead of the other two. So if three people all win, they're all winners, then the order in which you're chosen as one of those winners is not important. That would be a combination kind of situation. We'll talk a lot more about these things both in this video and in class. Remember, in a permutation, order is involved and or important, and in a combination, order is not. If you think for a moment about a lock that many of you have on your school lockers, we call the numbers that you put into that lock a combination. Now, just so you know, your locker combination is not a combination at all. It is a locker permutation. If you think about, and I'm going to try to draw this and it's going to be absolutely horrible, but if you think about a lock, okay, and you've got all these numbers all around and you're trying to open your lock so you can get in your locker, we call it your locker combination, but it's actually a locker permutation. Because let's say your combination, quote unquote, is 5, 10, 15. Is the order important when you put those three numbers into your lock? Yes, it is. You can't put these three numbers in any order you want. You can't say 15 and then 5 and then 10 and still get it to open. You need to pay attention to the order of your three numbers. So 5, 10, 15, the order is involved and important in opening a lock. So that's another way to help you remember the difference between a permutation and a combination is that you actually have a locker permutation on your lock, not a locker combination. Okay, so let's run through some examples and try to determine if these are combinations or permutations. Number 1, in how many ways can 5 books be arranged on a bookshelf in the library? Do you think that's a combination or a permutation that we'd be figuring out? Well, there's a key word in this one, and that is arranged. If you are arranging something, you're talking about putting it in a certain order. That word is usually a giveaway that this is a permutation. Okay, so that's a permutation because order is involved when you arrange things. Number 2, in how many ways can 3 student council members be elected from 5 candidates? Well, think about this one for a minute. When you think about the medals on the previous slide that I talked about, getting first place, second place, third place, order is involved there. How about 3 student council members? Well, it doesn't say you're electing a president and a vice president and a secretary. It doesn't give specific names. It just means 3 student council members. Well, that will be a combination. Okay, it's a combination because the order in which those 3 students are chosen as members is not important. They're just all members. Number 3, 7 students line up to sharpen their pencils. Okay, if you're standing in a line, are you in a certain order? Yes, you are. This is a permutation. It's more important if, it's not that important if you're first in line, but if you're first in line, that's different than if you're the 10th person in line waiting. You've got longer to wait. Okay, so it's you're in a certain arrangement, you're in an order. Number 4, a DJ will play 3 CD choices from the 5 requests. Okay, in this example, we're not talking about what order the 3 songs or CDs are going to be played in. We're just talking about, I really hope my choice, if you make a request to the DJ, I really hope my song gets chosen. It doesn't really matter what order it's chosen. Order is not involved here. We just want to know how many different ways could the 3 CDs be chosen out of the 5 requests. So that is a combination. Again, you're going to get a lot of practice on this if it's not all making a lot of sense yet. Okay, now in a specific example, once we've decided if something is a permutation or a combination, we are going to then need to calculate how many different permutations or combinations there would be in that situation. We're going to use our graphing calculators to help us do the calculations, though there is a formula we could follow as well, but we're going to use our calculator to compute these. So grab your calculator, pause the video, grab your calculator and make sure it's ready to go. Okay, so let's say we've got a situation. Let's say we've got a 3-digit code that we want to come up with, and we have the numbers or digits 0 through 9. So there are 10, 0 through 9 are 10 possible numbers we could use to make a 3-digit code. Okay, so the idea here, first of all, is this a permutation or a combination? Well, this is going to be a permutation because the order of those 3 digits in a code is important. So what we're going to do to compute or calculate the number of different permutations, or in other words, the number of different codes that we could create is the goal here. How many different codes could we make? So if I have a 1, 2, 3-digit code, I could put, let's say, 8 here and 3 here and 5 here, if that's my code. Okay? How many different codes could we come up with is our question here. So what we're going to use is we're going to use permutation or combination formula, and the formula, like I said, is going to be computed on your graphing calculator. What you're going to see on your graphing calculator is something called NPR or NCR. Now, you probably know right away that the P is going to stand for permutations and the C is going to stand for combinations. So whichever you decide you're going to use, that's the formula you're going to use, or the button on your calculator. So what do the other letters stand for? Well, N in both formulas, N stands for the total number of objects that you have. Okay, if you're arranging people, it's the number of total people you have. If you are selecting a code out of 10 total numbers that you can use, that's your total number. R, on the other hand, is the number of items that you are actually going to arrange. Okay, so in this situation, we are going to arrange 3 digits out of our 10 total possible digits that we have to use. So our 10 is going to go in for, 10 is going to go in for N. We're dealing with a permutation. We said order is important. And R is how many digits we are going to arrange, which is 3. So we are going to calculate something called 10p3 for this example. So we're going to use our calculator, and I'm going to just talk about the solution to this. I'm going to calculate this and let you know the answer, and then I'm going to show you the steps that I used on my calculator, both for the Casio and for the TI brand. After I compute 10p3 on my calculator, I should end up with 720. Okay, so therefore there are 720 different codes that I could make using the digits 0 through 9 if I want a 3-digit code. 720 different possibilities. So now I'm going to show you the steps. I'd like you to jot these down for both the Casio or the TI, whichever one you use, and then we're going to use those in future examples. Okay, so here are the steps both for the Casio and the TI. Go ahead, pause the video, jot down your 3 or 4 steps, and then actually go through and see if you can come up with that 720 answer that I got when I did 10p3. If you don't, that's fine. We will talk about it in class. If you do come up with 720, great. It sounds like you are on your way to understanding the process on your calculator. Okay, so now depending on if you understood those steps with your calculator, if you are interested, I think it'd be a good practice for you, go ahead and try to find the 4 answers to these questions that we had earlier using your calculator to compute either the permutation or combination. Again, P and PR is for your permutations and the NCR is for your combinations. Pause the video right now and then come back to see if you computed those correctly. Otherwise, we'll talk more about this in class. Okay, so the solutions are 5p5 should be your number 1, and that is 120. Number 2 is 5c3, which is 10. 7p7 is 5,040. And 5c3 we have again here, 10. Now just so you know, it just so happened with the examples I selected, in both of these cases with the permutations we had 5 and 5 and 7 and 7. That does not always happen. But this number will always be smaller than the number on the left. If you think about that for a minute, the number on the left is your total number of items that you have, and the number on the right is how many you are arranging or how many you are selecting. So again, a lot more on this in class. No worries if it seems confusing at this point.